In this video, we are going to talk about the examples of trigonometric identities. So, my example is prove that tangent square theta minus sine square theta is equal to tangent square theta times sine square theta. So, in order to prove that, what I'm going to do, I'm going to decide which side I want to take. So I have a tendency to consider left hand side first. So I'm going to consider the left hand side and then I will prove that left hand side can be converted to the right hand side. So basically my strategy is to take the left hand side and prove it to the right hand side. So I'm going to consider my left hand side. So I will write LHS is equal to, my left hand side is right here. So I will write tangent square theta minus sine square theta. Now, we all know that tangent theta is equal to sine theta over cosine theta. So, this is basically the relationship between tangent, sine and cosine. So, in place of tangent, I am going to replace tangent by sine over cosine. So I will replace this one by this. So let's write it down here as tangent is sine over cosine. So I will write sine theta over cosine theta. But this is the whole square thing. So I will write whole square minus my second term is sine square theta. So I will write minus sine square theta. Now let's simplify further. So as you can see, I have a square and I need to square sine and cosine. So I'm going to separate sine and cosine and square. So if I do that, I will write this one as sine square theta over cosine square theta minus sine square theta. Now, if you look at the first term is numerator over denominator, and my numerator is sine square theta and my denominator is cosine square theta. But the second term, as you can see, doesn't have a denominator. So I'm going to write 1 under sine square theta. So now you can see both the terms are in form of numerator and denominator. And in order to add or subtract this kind of expression, what I need to do, I need to make sure that the denominator of all the terms are the same. So basically somehow I need to make both the two denominators the same. So the denominator for the first term is, look at this, this is cosine square theta, but this one has 1. So somehow I need to make this one as cosine square theta. So what I'm going to do, I'm going to write sine square theta over cosine square theta minus my second term is sine square theta over 1. Now I need to make this one same as cosine square theta. So the easiest way I can do is I can multiply numerator and denominator by cosine square theta. So I'm multiplying numerator and denominator both by cosine square theta. The reason why, because I don't want to change the overall value of the expression. And in this way, I'm not changing it because cosine square theta over cosine square theta, they can cancel out and I will get 1. So basically, I'm not changing the overall value of the expression. So this will work. And what I'm going to do, I'm going to write this one as sine square theta over cosine square theta minus, let's simplify this one. So sine square times cosine square is sine square theta times cosine square theta, and at the denominator I have 1 times cosine is cosine square theta. Now if you look at both the two terms, you can see my denominator for both the two terms is same, which is basically what? Cosine square theta. So I can simply subtract these two terms. So I'm going to write this one as cosine square theta at the denominator, as you can see, and And my first term is sine squared theta minus my second term is sine squared theta times cosine squared theta. Alright? Now, as you can see, this sine squared theta is common for both the two terms. So I can easily take that term out and I can write this one as sine squared theta is out. So I can take that as a common, and inside the bracket I will left with what? 1 minus cosine squared theta over cosine squared theta. I just want to remind you the trigonometric identity that we talked about is sine squared theta plus cosine squared theta is equal to 1. And I need to find the value of 1 minus cosine squared theta. So what I'm going to do, I'm going to subtract cosine from both sides. And if I do that, I have this cancel out. And on one side I have sine squared theta left is equal to 1 minus cosine squared theta. So basically, for this thing right here, what can I do? I can substitute sine squared theta. So if I do that, I can write this one as sine squared theta, and this inside the bracket is also sine squared theta over cosine squared theta. Now, as we know, sine squared theta over cosine squared theta is what? Tangent squared theta. Because sine over cosine is tangent, so I will write sine squared theta over cosine squared theta as tangent squared theta times, I have this sine squared left. So I will write times sine squared theta. So basically I got tangent squared theta times sine squared theta. And if you look closely, this is my right hand side. So I will write right hand side. So basically, you can see we proved that left hand side is right hand side. Or I should say, we proved that left hand side is equal to right hand side. And this is how we'll solve problems or examples related to trigonometric identities.